The president of a local college claims that the average salary for those holding a bachelor's degree is equal to $54,000. A random sample of 49 people that hold a bachelor's degree was conducted to test this claim. The sample had a mean salary of $52,983 and a standard deviation of 4,250. Calculate the test statistic for a test of this hypothesis. Okay, so the problem is talking about testing a claim, but the main thing they're asking us to do here is just part of that process, which is to calculate the test statistic for a test of the hypothesis. So let's try to figure out what hypothesis they're talking about. So it says that a local college president claims that the average salary, so here claims that the average salary, so it's a claim about the mean, so I'm going to go ahead and write that down. I'm going to say, hey, the claim here is that the mean is equal to $54,000, so it's pretty straightforward, equal to $54,000. Now, if that's your claim, then of course you could derive your null hypothesis and your alternative hypothesis from that, and you'd be able to say, okay, the null hypothesis must be the same as the claim because the claim contains an equal sign, and that's one of the symbols that the null hypothesis uses. And then the alternative hypothesis would be not equal, so $54,000 again. And then from there, you kind of gather your data because you're going to need data for the test stats. Let's see what data they provided us with. We'll need a sample size. Generally, we will need an X bar, and we'll need a standard deviation. That's typically what's given. So it looks like they had a random sample of 49 people, so your N will be 49. It says that the sample had a mean, so your sample mean then is 52,983. And then finally, they say the standard deviation was 4,250. Okay, so there's your values. From there, you want to plug them into a test stat, and your test stat here would have a z distribution, and the reason for that is the sample size is large, so we'll go ahead and assume that we can use a z test stat. And the formula is this: it's x bar minus mu sub 0, sigma divided by the square root of n. Now, there's some things we have here, like we have x bar clearly, that'd be 52,983, and then we clearly have the square root of n, because the square root of 49 we can do. In fact, it's 7, we know that, but we can just write it in there. But we're missing a couple of items. So first of all, let's tackle this. This guy is supposed to be the population standard deviation. We don't have the population standard deviation, but it's okay to use the sample standard deviation as a substitute. So let's go ahead and plug that in, 4,250. So again, we'll use the sample standard deviation as a substitute for the population value when we don't have it. And then where does this guy come from? Well, it has a little subscript here kind of pointing to where you get that value. So it's saying, hey, look at the hypothesis over here that has the same subscript. And we look at the number that it's using and use that number. So in our case, it's going to be 54,000. Okay, and there it is. So let's go ahead and evaluate that test stat. So we'll do, in a parentheses, 52,983 minus 54,000. Close that up and divide by, open parentheses, 4,250 divided by the square root of 49. You could just type 7 here, but if you didn't know what that was, you just type in square root of 49 like that, close it up, press enter, and get minus 1.675 or minus 1.68. I'm going to round it off to 2 decimal places here. I'm going to go ahead and call this minus 1.68. Okay, and that's the answer to our question, which was, what is the test stat for the test of this hypothesis?